Good morning, third grade. Mr. Warner here, and I'm going to be going over lesson 12.1. Now, some of you may have already done 12.1, but we're going to use it as a review. If you've done it and it's brand new to you, then great. So lesson 12, in fact, all of chapter 12, is a lot of vocabulary. So you will need to possibly be looking into Spelling City, where there are some math vocabulary lists. You may want to be going over those so that you are prepared, because you will be tested on this vocabulary. First off is, let me go ahead and start 12.1 by doing something. What have I drawn? Look at it carefully. I know some of you are immediately going, you drew a line, Mr. Warner, but I did not draw a line. That is not a line. Yes, when we tell you in art class, or we tell you in class, get out some paper and make a line, this is what we want from you. But this in geometry is not a line. This is a line segment. It means it is part of a line, and we need to put endpoints on it. This is for geometry. We still want you to draw lines like that when we ask you to make a box and make lines in it. We still want those without the endpoints. But in geometry, we need endpoints. So this is called a line segment, and a line segment can be any length. It just needs to have the beginning and the ending to it with points, which brings me to another one, point. Point is any part in space, but for us on a line, I can put that there, and there is a point. It's a point. That is a single point. That is a single point. A point is one particular place in space, one particular place on a line segment or a line. It can begin the line segment, it can end the line segment, it can be on the line segment, but a point, single place. Okay, let's continue on a little bit. Let's take a look, and we'll use green now to be different. If I take my line segment and I add arrows onto either end, now I have a line. My line will go forever. You have to imagine it going through everything. You have to imagine it going past everything. This line will go forever. Now, it will not wrap around the earth because it would have to bend. If my line were up above us or below us or running this way, then it would cut through whatever was there, going into outer space, going past the moon, past the solar system to other galaxies. A line is indefinite, meaning it's supposed to go forever. That's what these little arrows on the other sides, or on both sides of this line mean. Means it goes forever. And lines can go in any direction. They can go this way, and they can go this way, and they can go just kind of a little bit both ways there. It's kind of parallel to this one. We'll talk about parallel later. Go this way. These are all lines going in their particular direction. This in geometry is a line. Next, one of the last things we have here is this guy. We have an end point right here, and we have half of a line. So we do not call this half of a line, we call this a ray. A ray starts at one point and then goes forever like a line. If I have two, then I have a line. This endpoint starts two different rays. I have a ray starting here and going this way on the line, and I have the ray starting right here and going this way on the line. These two rays, when together, going in a straight line like this, create the line. We do not have to have an endpoint in there. Like I showed you before, we could just have a line, and that's perfectly fine. But if we have a point in there, then we have actually created a line with a point on it, and we have two rays. We have a ray going this way and a ray going this way. You can think of a ray just like sunshine. So if I had the sunshine here, here's the sun, and we draw it like this, the middle of the sun, or somewhere on the sun, is the end point. The ray goes in one direction forever. This ray does not go to the other side and bend around. It just comes out from the sunshine and goes in one direction. Some of it, of course, hitting us on Earth, way over here. And there we are. And that ray will eventually come and get to us. But notice it's going in one direction. And that is why it's not a line of sunshine, it's a ray of sunshine. So we've got that ray coming our way. All of these items that we have been talking about are on what we call a plane shape. Plane shape. What do we mean by plane shape? Well, in this particular instance, a plane shape is one that is flat. It is on a plane. A plane in space is a flat area, but one that you can kind of, I'm going to kind of draw a little bit of a three-dimensional here. Okay, so kind of imagine this going in every direction forever, kind of like a floor or a ceiling, but super, super thin, just as thin as a piece of paper, but as strong as steel. That plane is a flat surface, and all the shapes that we are going to be dealing with today are flat. So when we draw a shape like a rectangle, it is flat. It is two-dimensional. We call it 2D. It is a plane shape. It is a flat shape. Plane or flat shape. Three-dimensionals would look something more like this. These two shapes are three-dimensional. We have, in this case, a rectangular solid, and we have a cube. Here in the rectangular solid, we have an edge, and this we have length, we have width, but we also have height. That's what makes this a three-dimensional solid. Again, we have length, we have width, we have height, and that makes this a three-dimensional solid. What we're discussing today are two-dimensional plane shapes. Now, there's a few other things you need to know about plane shapes, and one of them is sometimes they can be open and sometimes they can be closed. A closed shape is any shape in the world, as bizarre as you want to make it, but there's no way to get in, there's no way to get out. It is closed all the way around. A different kind of shape would be one that is open. An open shape, this is open. If I had some flies in here, this would not contain them very well. They would buzz their way out of this shape and come and annoy us. So this is called an open shape. Let's try to look at another one. And let's get a better expo marker here. Here we go. Open or closed? Well, this one would be open because we do not have the ends tied down. If I had some flies in here, they could buzz their way out of here and get out. So not quite a closed shape. Now, today they're going to be asking you mostly about these definitions. So if I had a shape such as this, how many line segments are there? When we do these types of things, we can mark on them like this to let us know we've looked at this one. That's one line segment from here to here, and you will not see endpoints on shapes. We just know they do come to those points. That point is actually called a vertex. You do not have to know this one. They will teach you this in 4th grade, but you're smart enough to know some 4th grade vocabulary. So the edges of these shapes are called vertices. That is the plural. So this vertex, we do not need an endpoint, but you could put one there if you wanted to just kind of see where those were. So this would be one line segment. This would be a second line segment. This would be a third line segment. 4, 5, 6, 7, 8. This has 8 line segments to it. 1, 2, 3, 4, 5, 6, 7, 8. Much like perimeter, you go around the entire shape, but in this case, we're not looking at adding up any of the sides. We're just counting how many segments there are to this particular shape. Okay, today, that is going to be the majority of 12.1.